Hi everyone. In the previous video, I talked about how you can download the textbook and how to use it for Comp 1000. In this video, I'll talk about the setup and draw functions, and I'll put some variables in there as well, but mainly the focus will be on setup and draw. The chapter that's relevant for this is chapter 3, which is interaction. The beginning of it exists. In this chapter from the textbook, there's a diagram on page number 35. On page number 35, there's a diagram for void setup and void draw. Void is the return type of the function. For the time being, we don't have to worry about it at all. Setup is the name of the function, and in the round brackets, we can pass parameters. Again, that's something that you don't have to worry about right now. You can think of setup and draw as two very special functions or pieces of code. Setup executes immediately when the program executes after the global variables, which we talk about in a little while. So setup executes once. So here you can see very nicely illustrated. It says do once. So steps 1A, 1B, 1C are executed sequentially once. And then it goes to draw, where there are two steps, 2A and 2B. But draw repeats over and over and over again. So it's steps 2A, 2B that execute, and then again 2A and 2B execute, and then again 2A, 2B execute over and over again. So it's like a loop, but it's not really a loop as such. But we'll talk about that more later. Anyways, we're going to write a simple program. So as I said, void setup, nothing in the round brackets. Leave a space between the round bracket and the curly bracket for consistency. You will notice that when I enter the setup function, it automatically goes 2 spaces ahead. You can also make it 4 spaces, 8 spaces by configuring processing preferences. Again, if I press enter, it goes 1 tab or 2 spaces ahead. Let's try that one more time. If you close setup, you'll see that the closing curly bracket automatically goes to the same level. And if my cursor is after the closing curly bracket, it also highlights the opening curly bracket. So it does scope matching. You leave a line and then add the function draw. Same logic. Again, you press enter and close it. So this is an example where we have defined the functions, but the functions are not doing anything. Let's just run this program, and you'll see that there's a sketch that runs, but doesn't do anything. What I'm going to do is, I'm going to write println inside draw, and inside setup, I'm going to write println inside setup. We saw println statements in today's lecture. You are inside println, you've got these double quotes, and in the double quotes, whatever you type is displayed straight away in the console at the bottom of processing. Now, because I said that draw runs over and over and over again, the default number of times it runs in 1 second is 60. That's called the frame rate. So if I run this program now, it will run really, really fast. And you can see that too many draws are there. So I'm going to just slow it down by controlling the frame rate of the program and saying, I just want 1 frame per second. Let's run this. Inside setup, then inside draw, then inside draw, then inside draw, again and again and again, but in a rather slow manner. Okay, let's try that one more time. I'm going to maximize processing screen and expand this a little bit, stop execution and run it again. Setup runs once, draw runs once, twice, thrice, 4 times, 5 times, 6 times, 7 times, 8 times, and over again. Okay, so that proves empirically that draw is repeating itself. Now, what do you do inside setup? So because setup executes once, typically, well, not typically, almost always, you will define the display window size inside setup. And you also erase the background in the beginning to the background that you want. So in this case, let's say I want background size 0. Let's run this. And you get a black background. I can change the screen to 400, 200 and change the background to 255. This time it's a 400 pixel by 200 pixel screen and the background is white. So why have draw? We have draw because we can draw a sketch and make a minor adjustment to the sketch and then draw it again. So that will give us the sense of a flip book or animation, but we'll get there in a little while. Just to test out draw, what we'll do is we're going to just draw a random line. Now, for this, we are going to invoke the random function. So before I do that, let me just display what happens when I display a random value between 100 and 200. Random is a function call, just like rectangle, ellipse, circle, etc. Random is a call, but unlike circle and rectangle, which display a shape, random evaluates to a value. Random 100, 200 might evaluate to 100.0 or 100.00001 or 100.00002, and so on and so forth till 199.9999, but not 100. So this gives me a random number generates, or I should say evaluates to a random number in the range 100, including 100, which is what the square bracket represents, to 200, which is what the round bracket represents, that it's exclusive. Okay, let's just run this, and you'll see that 191.00, 111.82, 183.36, and so on and so forth. So it's always going to be between 100. What I'm going to do is, each time, I'm going to use that value as the diameter of the circle I want. So I can draw a circle which is always at the center of the screen. We did width and height in the lecture today, so please take a look at the lecture. And its diameter is randomized. The problem is, if we draw a smaller circle on a bigger circle, you won't see the difference. So let's just run this and see. Okay, so you see it. Okay, fine. Because we don't have, because we have a stroke, you can still see something outside, which is good. It would be even better if we erase the background every single time. So what we're doing is we are erasing or clearing the previous output and then draw a fresh output. Let's fill it with red color and let's no stroke. Let's try it again. Now what we're expecting is going to happen is every time draw executes, it's going to clear everything, then it's going to change the fill and stroke, and then it's going to draw a circle. Let's run this. So every time a new circle is drawn. If you have multiple shapes, then these multiple shapes are not drawn one at a time, they're drawn all together. So to illustrate that, I'm going to reduce the size of the circle between 20 and 50. I'm also going to draw a vertical line at a random location, but if I want to draw a random line, then I have to use the same value twice. So let's do this. I want a random line between 0 and width by 4. And start at y equals 0. Then I want to use the same value because I want a vertical line and all the way to the bottom height. But this won't work. But this won't draw a vertical line, which is what I want. And let's do this before no stroke. And the stroke for this line is 3, and the stroke color for this line is green, let's say. So it's going to draw a line, but it's going to be kind of slanted. It will be in the first quarter in terms of width, but it won't be a vertical line always. Let's have a look at it and see what happened. So you can see that it generates a line fine, but it's not vertical. That's because this is the first invocation of the random function, which evaluates to a value. Now it might evaluate to value like 10 or 20. And then again, we have a second invocation of the same function, which might evaluate to a different value, which can be 40, 50, 60, something like that. If you want the two values to be the same, you need to pre-compute it and keep it in a variable. So we're going to keep it, we're going to cut it. You can declare a variable of type float by saying float x is a random value. And then we are using the same value of x at both places. Again, I explained how to declare and initialize variables in the lecture, so please take a look at that. Now we know that this will draw a vertical line, definitely. Let's run this. And it's always vertical every time it's at a different location. So the first thing is that we have a line, then we have a circle, and in the third half of the screen, I'm also going to draw a little square. So the square is always at 3 times width, or let's say 4 times width divided by 5, so it's at 80% of the way. Its height is randomized. Its height is randomized between 0 and height by 2, so it's always in the top half. And the side is always 20 pixels. I'm going to change the fill color to 00 to 55 for the square. So we have 3 shapes, green, red, and blue. Let's take a look at it. So every time we get 3 shapes. What I want to show is that these 3 shapes do not appear one at a time on the screen. What processing does is when it executes draw, it starts collecting output in a buffer. So it keeps everything in a buffer. So now the buffer is clean. Now the buffer has a line on it. Then the buffer has a circle as well. And finally, the buffer has a square as well on it. So it collects everything in a buffer. And when it reaches the end of draw, it pushes that buffer onto the display window. So if you draw 20 different shapes inside draw, they're all collected and pushed onto the display window at the same time. So when I run this, I get all 3 shapes at the same time. Notice that I had reduced the frame rate to 1. If I get rid of that, so if I comment that out, it's really, really fast because it's 60 frames per second. So that's a sample program that explains how setup and draw work. Thank you very much and have a good night.